All right, y'all, this is going to be note card 26. It's called the derivative of an inverse function. So Stacy gives us some steps here, but I think this is kind of hard to understand. So I just want to kind of do an example that hopefully will make all that information a little bit more clear. Okay, so let's say I have some function which we call maybe y equals x squared plus 4. Okay. If I graph this function, okay, I can put in, let's just make a table of values here, x, y. Okay, so for instance, if x is -1, -1 squared is 1, plus 4 is 5. If x is 0, 0 squared plus 4 would be 4, +1, 1 squared, 1 plus 4 is 5 again. Okay, so if I plot these points, -1, 5, that's here, 0, 4, that's there, 1, 5, that's there. This is going to be a parabola opening up. Now, let's just kind of review. Let's say I wanted to figure out what y prime was. Hopefully you could say right away that the derivative of this function would be 2x plus 0. Okay? And let's say I care about the slope at a value of 1. Okay? So I want to draw in a tangent line right there at an x value of 1. Okay, or if we think about it at the point, this is the point 1, 5 on the graph. Okay, so if I plug in 1 here, 2 times 1 is 2. So when I draw in this tangent line, the tangent line is going to have a slope of 2. Okay, so hopefully none of that is that hard yet. Okay. Now, how do I find the inverse of a function? Okay. Well, if I want to find the inverse of a function, we start with the original function, and what I do is everywhere I see a y, I'm going to write x. And everywhere I see an x, I'm going to write y, but I'm going to keep the rest the same. Okay. All right, so if you were to actually graph this function, if you wanted to graph the inverse function, here's the inverse function. Okay, it's not actually a function though. Okay, think about these 3 points. Basically, what it does, okay, on the inverse function, all of these x values become the y values, and all of these y values become the x values. So here, 5, 4, 5 are the y values, so you can just switch the table around a little bit. And the x values are -1, 0, and 1 on the original, so on the inverse, those would be the y values. So if you plot these, if I plot 5, -1, that's there, 4, 0, that's there, and 5, +1, that's there. So you can see why this is not a function. This is the inverse actually is a parabola opening up to the right. Okay? These 2 graphs are inverses of each other. Okay? Now, let's say we wanted to figure out what the slope was. Now we saw that this point here that I focused in was the point 1, 5. The inverse point would be 5, 1. So now I'm going to focus in on this point. Okay, I'm going to focus in on that point, 5, 1. What you will find, or what the top of that note card says, is if I draw on a tangent line to the inverse graph, the slope of this, okay, the slope right there is going to be equal to the reciprocal of that. Okay, so the reciprocal to 2 is 1/2. Okay, it's another positive slope. It looks like it's going up, but the slope of it is the reciprocal to 2. Remember, this is like 2 over 1. Okay. So what does that mean? Okay, so here's the big idea. All right. If I want to take the derivative of an inverse, okay, the derivative of an inverse, okay, at a certain y value on the original, that's going to be equal to the reciprocal like that. That's the big takeaway. So let me put these two relations, let me use Desmos real quick, and I can kind of show you what it is right there. Hold on. So here was the original, y equals x squared plus 4. Okay, so at the point 1, 5, which is right there, if I drew in a slope right there, a tangent line, it would have a slope of 2. Okay, that would have a slope of 2. All right. If I draw in this other function, x equals, it's not a function, but the relation, x equals y squared plus 4. So the slope here is 2. Okay, the slope there is 2. Slope of the tangent line is 2. Okay, but the slope here at 5, 1 would be 1/2. So thinking back to the example here, so if I wanted to write it here like f inverse, okay, or I should say f inverse derivative at that x value, okay, at that x value, 5, okay, equals 1 over f prime at that x value of 1. Because we said that was 2. That's the best way to think about it. So let's do some of these problems and hopefully we can understand a little bit. All right. So number 1, it says if g is the inverse of f and both functions are differentiable, and f of 2 equals 3, find the value of g prime of 3 for f of x equals x cubed over 4 plus x minus 1. Okay. So let's kind of write down the important pieces of information. So here I know that g is the inverse to f. Okay, so I could also write that as g of x equals f inverse of x. And that's how we write f inverse. Okay, no big deal there. All right, now what else do they tell me? They tell me that f of 2 equals 3. What does that mean? So that means I have a point on f when the x is 2, the y is 3. They also tell me that f of x, they give me the equation for f of x. It says x cubed over 4. I'm just going to rewrite that as 1/4 x cubed plus x minus 1. Okay. So here's all the information I have about f so far. Before I do anything, I should know at least one point on G. Since G is the inverse of f, if the point 2, 3 is on f, then if I reverse those, the point on G is 3, 2. Okay. And what the question's asking me to find, it says find G prime of 3. Okay. Notice that that's the x value on the inverse. Well, here's how I'm going to do it. Here's the x value on f. Let's figure out what f prime of 2 is first. Okay. Before I can figure out f prime of 2, I need to find f prime of x. Okay. So using my power rule here, this would be 3/4 x squared plus, remember this is a 1x to the first, so the derivative there is just 1. The derivative of a constant is 0. Now let's figure out, this is the x value. Let's figure out what the slope of the tangent line would be at this x value. Again, it matches up with the x value. Okay, so if I plug 2 into this function, I would get 3/4 times 2 squared plus 1. Okay. Well, 2 squared is 4, and this 4 cancels out that 4. So I'm left with 3 plus 1, which is 4. So using these rules, basically, okay, if that's 4, then G prime of 3 would be 1 over f prime at 2. So that would be 1/4. That's all we have to do for it. That's all we have to do for that problem. Let's read the next one. Number 2. It says two functions h and h prime with values given in the table below are differentiable everywhere. So that means you can take the derivative everywhere. Find the derivative of the inverse at x equals 4. So what they're asking me to do here is they're asking me to find the inverse derivative evaluated at 4. Okay. So what does that mean? That means the points on h inverse, they're giving me the x value. Okay. So the point on there is 4 something. What does that mean the point is on the original function, h? Well, if this is the x value on the inverse, it would be the y value on the original. Okay? So let's use this information here. Let's use information about h. When is the y value 4? What's the x value there? It's 3. So if the point on h is 3, 4, using the table, the point on the inverse would be 4. This is the x value here. It's going to be the y value there. Okay, so that would be the point on the inverse. You just switch x and y. Okay. So what is, on this one, what is h prime of 3? Okay, because again, what's the slope of the tangent line at 3? So go over to h prime. H prime at 3 is -7. Therefore, the derivative of the inverse at this x value would be the reciprocal to this. Okay, it would be the reciprocal to -7. What's the reciprocal? I'll write it like this. It would be 1 over h prime at 3. So it would be 1 over -7. So -1/7 would be the answer there. Okay, so I always like to think about these as points and derivatives. It's the easiest way to think about it. Okay. All right, let's try number 3. I want to know what is the equation line of the tangent line to g of x at x equals -3. So let's think about what we have. We have the original function, which we're calling f, and then we have the inverse function, which we're calling g. It tells us that g is the inverse of f. Okay. So what do we know about function f? From this part right here, we get a point on function f. The point is 2, -3. So right away, I should know that the point on the inverse relation or function, I don't know if it's a function or not, but I know that the point there would be -3, 2. Okay. Now, I do know what the derivative here is, f prime of 2. It tells me that here as well. It says that's 3/4. So if I want to figure out g prime at -3, again, the same x value, it would be the reciprocal to 3/4, which is 4/3. They want to know what's the equation of the tangent line to g. So here I have all the information I need. There's my point, and there's my slope. So the right answer would be y minus 2 equals 4/3 x minus -3. Now let's try number 4, and I'll do it on the back because I'm running out of room. So here's what it tells me in number 4, and I will need a calculator for this one. It says f of x equals 2x plus the cosine of x. And it's asking me to find the derivative of the inverse evaluated at 1. So what do I know? This is the x value on the inverse. Okay, so on the graph of the inverse, I know a point. I know the x value of the point. That's 1. Okay. I don't know the y value yet. So coming over here to the graph of f, what I know is that the y value over here will be the same as the x value over there. Okay. Now, how am I going to figure out the x value here? I'm going to take my function and set it equal to 1 and figure out what value of x makes that true. Okay. So you're going to make sure you're in radian mode here. Okay. And let's go ahead and put in the f function here. So 2x plus the cosine of x. Okay. And let me also, I want to basically figure out where that equals 1, so I'm going to put in the line y equals 1 here. And I'm just going to do zoom trig since the first one's a trig function. Okay. So we want to figure out what the x value is where they come together. So let me zoom in a little bit so we can see this a little bit more clearly. Somewhere really close to an x value of 0. We could even, if I had trace, I could even zoom in right there. So there's the trig function coming in, and there, and here comes the line y equals 1. So if we go second trace, I can calculate the intersection. First curve, enter, second curve, enter, guess, enter. Tells me that the intersection here is 0, 1. Okay. Probably didn't need a calculator for that, but if you want to verify that's true, 2 times 0 is 0. Cosine of 0 radians is 1 on the unit circle. So on the graph of f, the point is 0, 1. Okay. So over here, the point on the inverse is that. Okay. Let me get rid of this y2 equals 1 real quick. And let me go back to zoom trig, or standard. Let's put that trig graph back in. Okay. There's actually a way the calculator will do an inverse for us. Here's how we do it. If we go second and then hit program, above it it says draw. And so if I go to that, okay, if you see number 8, it says draw inverse. So if I click that, I want to draw the inverse to what's in y1. If I hit enter, here comes what the inverse graph would look like. That's what it looks like. And if we want to see more of it, let me just kind of make the y values a little bit bigger. So here comes the original. And I'm going to have to re-enter. If I ever change my window, I have to draw the inverse again. Okay, so that blue curve is the inverse curve. Okay. So since 0, 1 is a point on the red curve, 1, 0, it's right there, is a point on the blue curve. Now, what I want to figure out is what's the derivative at that x value of the inverse. So let's come back over here and let's do stuff we know how to do. Let's figure out what the derivative is for just the graph of f. What's the derivative of 2x? It's 2. What's the derivative of cosine? It's negative sine. Now let's plug in that x value. So it'll be 2 minus the sine of 0. The sine of 0 radians is 0. So that's 2. Okay, this curve in red, I go second calculate. I calculate number 6, calculate the derivative at a point. If I do it at an x value of 0, notice the derivative there is 2. Okay, but what I really want to find is on this one right here, I want to find what the slope of the tangent line to this blue curve is. Okay. So what I'm trying to find is what is the derivative of the inverse at 1? It's the reciprocal of this. The reciprocal of 2 is simply 1/2. So if I drew on a tangent line right here, that tangent line would have a slope of 1/2. But right there it's 2. 2 on the original function, it would be the reciprocal, it would be 1/2 on the inverse function. So that's the easiest way that I have found to do it. Okay, think about points and think about derivatives. As soon as you know what the derivative of the original is, okay, the derivative of the inverse is the reciprocal to that. Easiest way to do it. You don't see these type of questions a lot, but every once in a while they'll throw one on. Okay. So on your packet, you have more practice with that this evening. Okay. And then when you get to the second page, okay. Okay. They want you to go through some steps on, okay, here's the original function. They want to know what f prime of a is. Okay. They want to know what f inverse, the equation of the inverse function. They want to know what the derivative of the inverse function is. And they want to know what the derivative at that b value is. Okay. So for example here they tell me, they don't give me the a value in the first problem, but they do tell me the y value is -2. So if I just do some algebra here, plug -2 in for y, plug a in for x, and solve it out. So add 2 to both sides. And that would be 0. 0 equals 4a. Divide both sides by 4. And I know right away that a equals 0. So now they want to know what f prime at that a value is. So in this case, they want to know what f prime at 0 is. Before I can find f prime of 0, I need to find f prime of x. Okay. So f prime of x, what's the derivative of this? It would just be 4. Okay. So what these two columns do, it tells you about the point and it tells you about the slope of the tangent line at that x value. Okay. Now, these two columns just give you practice with the derivative, but with finding inverses and finding derivatives again. But what's really important is this last column. Since the slope at 0 was 4, that means for f prime derivative, or inverse derivative, evaluated at -2 for that b value, because remember, on the inverse, the point is BA. So in this case, it's -2, 0. Okay. Well, if that slope was 4, this slope would be a 4th, because that's the reciprocal. And now, how do you actually find the equation of the inverse? Switch the x and y, so this becomes x equals 4y minus 2, and then solve for the new y. Solve for that y. So add 2 to both sides, then you can divide everything by 4. So the inverse equation would be x plus 2 over 4, or you could even write it as 1/4 x plus 2 divided by 4. You can simplify that and say 1/2. And then if I wanted the derivative equation for any x value, just take the derivative of this thing. So here the derivative always equals a 4th. It doesn't depend on the x value. So even for the specific -2, there's nowhere to plug in -2, so it just stays a 4th. So that's what that's asking me to do. I'll do maybe a couple of these problems on the first page with you, just so you get the hang of it. Okay. So number 1, it says, let f be the function defined by this. Okay. It says, okay, g is the inverse function. And it tells me that 2, 1 is a point on f. what is the value of g prime of 1? So the original function is f, and g is the inverse function 2f. Oops. I probably should have done this in the other color, sorry. Alright, so let's do f in green. F is the original function, g is the inverse. Okay, so just think about it like points and slopes. That's the easiest way to think about it. So on f, the point is 2, 1. That means the point on g is 1, 2. What I'm trying to figure out here is g prime of 1. That's what I want to find, and that's going to be the reciprocal to this derivative, evaluated at 2. So here, f prime of x, take the derivative of that, that would be 5x to the 4th plus 2. Okay, so if I wanted to figure out what's f prime at 2, I would just plug 2 in here. 2 to the 4th, that's 16, times 5, that is 80, plus 2. So the derivative there is 82. Okay. What does that mean about this? The reciprocal of 82 is 1/82. So one more practice problem here. Okay. So I have information about some stuff about f. I'm just going to put that in blue. Okay. So it tells me here, so I have some stuff about f, and it tells me that g is the inverse. Okay. So g is the inverse function. What they want me to know, they say, what is g prime of 4? That's what I want to know. Well, this is an x value on g, or g prime. So the point on g has an x value of 4. What does that mean? What's the point I care about over here? If that's an x value of 4, over here it's going to be a y value of 4. Okay. So look at these 2 points that they give me information about. Which one of these has a y value of 4? Well, f has 2 points it gives me information. One is 4, 9 that it gives me information about it, and the other is 8, 4. That's what these 2 pieces of information tell me. I care about the one with a y value of 4. Okay. So the point I care about over here is 8, 4. So if this is the point 8, 4, this is the point 4, 8. Okay. So when I think about the derivative over here, I need to look at f prime at that x value. Okay. That's going to be one of these 2 numbers. You got to figure out which one's right. Well, it's this one that I care about. So the slope of the tangent line there is -3. Okay. So if this slope is -3, this slope over here is going to be the reciprocal to that. So it's going to be -1/3. Number 3, I'll help you set it up. So here they're asking you to find h prime of 10. They tell you h is the inverse. Trying to figure out what h prime of 10 is. That means that the point comes from 10 something. G is the original. And they give me the equation of it. So if 10 something is the point there, something 10 is the point here. So how are you going to figure out what this x value is? You're going to have to set this equal to 10 and use your calculator to help you solve it. Okay, it might be a decimal. As soon as you find this x value, call it a, get an equation for g prime of x, then find g prime of a. Point over here would be 10 comma a. Now as soon as you know what g prime of a is, okay, h prime at 10 is going to be equal to 1 over g prime at a. To me it looks like it would be some decimal. Probably a number fairly close to 1, some decimal close to 1. Maybe like 0.8 or something like that. You don't actually know until you test it out. Maybe 0.8, 0.9, something like that. Okay. Then try the next couple problems. There's some review problems on the back of here. So maybe we'll work a couple of these. It says find the derivative of 1 over f plus g. Well, you could also write that as f plus g, okay, to the negative 1. I want to know what the derivative of that is. So how do you find the derivative of this? Okay, well, I can use the chain rule. So I'd bring the negative 1 out front. The inside stays the same. We reduce the power by 1. Then you multiply it times the derivative of the inside. So the derivative of f would be called f prime. Okay. Plus the derivative of g would be called g prime. So if we want to kind of rewrite this, that's negative 1 over f plus g squared times f prime plus g prime. Okay, now they want to know what the actual value is at negative 1. Alright, so just looking at this, that means I need to take negative 1 over f of negative 1 plus g of negative 1, square it, that's what this part is, and then multiply that times f prime at negative 1 plus g prime at negative 1. Then I can use my table of values to help me figure this out. So that's negative 1 over f of negative 1 is 4 plus g of negative 1 is 5 times f prime at negative 1 is 7 plus g prime at negative 1 is 2. So if we do some simplifying here, 4 plus 5 is 9, squared is 81, so that's negative 1 over 81. 7 plus 2 is simply 9, and then you can reduce that. That's negative 9 over 81, or you can say negative 1/9 if you simplify it. Okay. Look at this expression, that's a quotient. So what you would have to do is use the quotient rule. Here is an inverse. Okay. So what they want to know is they want to know what the inverse derivative is at negative 1. Okay. So that means that the point on G inverse is negative 1 something. Okay. You got to use the table to help you figure that out. That means that the point on G would be something negative 1. Okay. So look at these values here. Which one has a y value of negative 1? It's right there. That comes from an x value of 4. Okay. So if here the x value on G is 4, that means the y value on G inverse is 4. So here, you could figure out what g prime of 4 is, that x value, by looking at the table. G prime at 4 is pi. So over here, the inverse derivative evaluated at -1, which is what the question's asking for, is the reciprocal to pi. So what's the reciprocal to pi? It's 1 over pi. And that's done at that point. Then down here at the bottom, you have more examples using a new table. Okay. So just give those a shot tonight. And that's going to be it for this note card. Derivatives of inverses.